Scientific notation is also known as standard form. In this video, we shall be talking about how to express numbers and carry out arithmetic operations, expressing them in standard form. At the end of this lesson, learners should be able to express given numbers in scientific notation, aka also known as standard form. Learners should be able to carry out division, addition, multiplication, and subtraction operations in standard form, which are the basic arithmetic operation. I'm Abdullah Falade, your mathematics instructor. Why do I need to express numbers in standard notation? Expressing number in standard notation is of importance because it helps to reduce the stress of writing numbers with large digits. A number is said to be in standard form if it can be written in this form: a times 10 raised to power n. So this a has to be a number that is greater than or equals to 0, but it has to be less than 10. It should not be 10. And the n, it has to be either a positive or negative integers. Let's look at example 1. We need to express the following in standard form. The first one is 365. How do we express this in standard form? To express this in standard form, you take the decimal point. Don't forget that 365 is the same thing as 365.0. So you need to take the decimal point, you need to take it back to the front of the first non-zero digit. And what is the first digit that is not 0 in 365? That's 3. So we take it back 1, 2, and we have 3.65 times 10 raised to the power plus 2. So that's why we said whenever you move backward, you make sure your n is positive, BP. This is not blood pressure, okay? Just a notation, just a way to get it right, so that whenever you need it, you can easily recall, okay? So B, we have 6,000, which is 6 points. So you take the decimal point back to the front of the first non-zero digits. 1, 2, 3. We have 6.000 times 10 raised to the power plus 3, and that's BP. Backward positive. What if you have to take the decimal point to the front? 1, you need to move forward. 2, 3, 4, 5. We have 5.69 times 10 raised to the power minus 5. So you are moving forward and it has to be negative. We have Fn, and as we have negative 5 as our n. In the next one, we also need to move forward here because we need to take the decimal point to the front of the first non-zero digit. 1, 2, 3. That's why we have 7.48 times 10 raised to the power minus 3. And here we also have a 164,000, meaning 164,000.0. We take the decimal point back. 1, 2, 3, 4, 5. So when you move backward, don't forget positive, and that's why we have 1.64000 times 10 raised to the power plus 5. So our second example will be on how to carry out DAMS, division, addition, multiplication, and subtraction operations, and writing the answer in standard form. Simplify the following and express in standard form. The first one, 365 times 400. If you express 365 in standard form, it gives 365 times 10 raised to the power 2, and 400 also is 4.00 times 10 raised to the power plus 2. So you can observe that the operation all through is multiplication after being expressed in standard form. So it's easier. Just multiply the a by themselves. 3.65 times 4, you have 40.6, and you can see 10 raised to the power plus 2 times 10 raised to the power plus 2. So in our previous video we have explained the laws of indices with examples. You can watch that in our previous video and you'll be able to see how to apply laws of indices. So you can see from there we have 4.6 times 10 raised to the power plus 4, because by laws of indices this will be plus 2 plus 2, which is plus 4. But mind you, 14.6 is not yet in standard form, so we express it in standard form by writing 1.46 times 10 raised to the power plus 1 times 10 raised to the power 10 times 10 raised to the power times 10 raised to the power 4, and finally we have 1.46 times 10 raised to the power 5, because by the laws of indices plus 4 plus 1 plus 4 gives plus 5. So for B we have 500 divided by 6,000. 500 can be expressed in standard form 5.00 times 10 raised to the power 2, also 6,000 as 6.000 times 10 raised to the power 3. And here you have to be very careful. 5 divided by 6 times 10 raised to the power 2, also divided by 10 raised to the power 3. And by the laws of indices you subtract the power, that's 2 minus 3, and we have minus 1. Mind you, this is here to be in standard form. After we punch our calculating device, we have 5 over 6 to be 0.83, so we express further 0.83 to be in standard form, and we have 8.3 times 10 raised to the power minus 1, and this 10 raised to the power minus 1. Applying the law of indices, we have 8.3 times 10 raised to the power minus 2. So for C we need to add 0.000025, you need to add it to 0.0000569. So whenever you are dealing with addition or subtraction operation, take note, always express them to have the same exponent. What do I mean by this? You can observe that we are able to express this as 2.5 times 10 raised to the power minus 5, which is exactly the expression of this in standard form, and also 5.69 times 10 raised to the power minus 5, also in standard form. So they are now having the same exponent, 10 raised to the power minus 5, 10 raised to the power minus 5. So it's easier to add 2.5 with 5.69 times, so we have 8.19 times 10 raised to the power minus 5. So be careful at this point, don't go and make any alteration to this 10 raised to the power minus 5, 10 raised to the power minus 5. It's like you are writing 2.5x plus 5.69x. It will give 2.5 plus 5.69, everything in bracket x. So our x in this context is 10 raised to the power minus 5. So don't go and make that mistake by adding 10 raised to the power minus 5 by 10 raised to the power minus 5, okay? So what you need to do is to make sure whenever you are dealing with addition operation, make sure you're able to express them to have the same exponent, which is 10 raised to the power whatever you have, okay? In the last one we have to subtract, and mind you, when you express 0.00748 in standard form, you have 7.48 times 10 raised to the power minus 3. The same thing with 0.0009, we have 9.0000. So you know 0 after the decimal point is nothing, that's why we have shortened it to be 9.0 times 10 raised to the power minus 4. And mind you, this is 10 raised to the power minus 3, this is 10 raised to the power minus 4. They're not the same, and you have to make them to be the same, okay? So 7.48 times 10 raised to the power minus 3. We also need to express this to have 10 raised to the power minus 3, and that's why we have 0.9 times 10 raised to the power minus 3. So by there you can now subtract So you cannot have 7.48 minus 0.9, and by the time you do that you have 6.58 times 10 raised to the power minus 3. So this is how you can express number in standard form after simplification. So exercise, do it yourself, DIY. Simplify and express your answers in standard form. We have the first one, 1535 times 5025. The second one is 0.00025 minus 0.0036. The third one, 1025 divided by 500. And the fourth one is 0.000005 450 divided by 0.000225. We also have 10025 minus 0.00063 plus 36.15. So we come to the end of this video. I hope you have learned something today. Please press like, share and subscribe for the next video. Bye for now.